Hello, visiting alpha male grey kangaroo. How would you like to hear about global warming? I have a lovely article here and I am prepared to read it to you. Yeah, you can't hit the camera. No, you can't hit the camera. Back off. It's alright. That's right. That's alright. You calm down. And I'll read to you about global warming. We have this lovely magazine called New Scientist. This New Scientist magazine is the 17th of November 2012. Look, we're going to talk about global warming, okay? Very important subject. And will you calm down, Rastus? Here we go. Cover story. Global warming. 5 years ago, the last report of the Inter-Govenmental Panel on Climate Change painted a gloomy picture of our planet's future. As climate scientists gather evidence for the next report due in 2014, Michael LePage gives 7 reasons why things are looking even grimmer. 1. The Arctic is warming even faster than predicted. Not so long ago, the Arctic Ocean was covered by thick sea ice several years old. Even at the end of summer, more than half of the sea surface was still shrouded in ice. As the world warmed in the past decades, the winter refreeze has stopped, compensating for the summer melt. Heat-reflecting white ice has given way to heat-absorbing dark water. Snow has melted ever earlier on surrounding lands, more heat-trapping moisture has entered the atmosphere, and bigger waves and storms have assailed weakening ice. Thanks to these feedback processes, the Arctic has begun to warm twice as fast as any other region on the planet. By the late 1990s, the extent of sea ice had fallen to its lowest level for at least 1,400 years. At the end of this summer, only a quarter of the Arctic Ocean was still covered in ice, a record low in modern times. And the total volume of the ice was just a fifth of what it was 3 decades ago. See record Arctic ice loss below. What's left is a thin layer that melts easily. Here we have a diagram of Arctic ice loss. In blue we have the figure for 1982, and in black we have the figure for 2012. Scale up the left is millions of square kilometres. So in 1982 there were 15 million square kilometres of ice in the Arctic in summer. 2012 there's 13 million. So we've lost 2 million square kilometres of winter ice. In summer there was 6 million and there's now 2.5 million square kilometres of ice in the Arctic in summer. It wasn't supposed to happen this quickly. In 2007, when the Inter-Governmental Panel on Climate Change, the IPCC, issued its most recent report on the state of the planet's climate, the consensus was that the Arctic would not be ice-free in summer until the end of the century. We might have been unlucky. Natural variability might have accelerated the ice loss by pushing old, thick ice out of the Arctic. But climate models clearly underestimated the pace of change too. Older models lacked important details, such as the melt ponds on the surface of sea ice that absorb more sunlight. The latest models, which include more processes, still suggest it will be several decades before the first largely ice-free summer occurs. But if current trends are a reliable guide, such summers will happen within a decade. However long it takes, the continued ice loss will have many knock-on effects. These could include more extreme weather in the Northern Hemisphere, faster melting of the Greenland ice sheet, and greater releases of carbon currently locked away in permafrost. Other, even nastier surprises might also lie in store. Paul Valdez at the University of Bristol, UK, points out that relatively small changes in the Earth's state, orbital changes, shifting ocean currents, and so on, have in the past produced abrupt climate changes. Some 5,500 years ago, for instance, the lush savannas and wetlands of northern Africa turned into the Sahara Desert over centuries. or perhaps just decades. Older climate models produce such dramatic change only in response to big disturbances. It is not yet clear if the newer models are any better in this respect. They may be giving us a false sense of security, says Valdez. Well, I'm glad you calmed down, old fella. Much better that you sit there and quietly eat. And just listen to the state of the art. 2. Extreme weather is getting more extreme. In 2010, Russia sizzled as the temperature hit nearly 40 degrees Celsius in several cities. In 2011, the Groundhog Day blizzard dumped an astonishing amount of snow across the eastern US and Canada. This year too has been one of extraordinary weather, from summer deluges in the UK to a storm knocking out power to millions in the US during a record-smashing heatwave, and of course the devastation wrought by Superstorm Sandy. Such events fit a pattern. In a warming world, shifting rainfall and increased evaporation will lead to more droughts. A warmer atmosphere holds more water, making rainfall at times more intense. It is difficult, though not impossible, to say how individual events are influenced by climate change. It is simpler to tell whether the overall numbers are increasing. Even at the time of the last IPCC report in 2007, the trends for extreme heat, droughts and intense rainfall were clearly already upwards. Not only are these trends continuing, but the weather is also becoming even more extreme than was predicted. For instance, a study this year of ocean salinity data from between 1950 and 2000 by the Australian Commonwealth Scientific and Industrial Research Organisation, the CSIRO, and that is the same CSIRO which has evaluated the results of my SunFoil project and decided that there is no bullshit in my story. To see that little segue, search SunFoil short talk, SUNFOIL, one word, short talk with a hyphen between the two of the second and the third words. The SunFoil project, to save fuel and reduce carbon emissions. That okay with you? SunFoils are a good idea, according to a kangaroo? Yeah, I know, you got a sore hand. I can't do anything about it? No, I'm not going to try orthopaedics on a wild kangaroo's hand. So according to the Commonwealth Scientific Industrial Research Organisation, CSIRO found that the global water cycle, the rate at which water evaporates and falls as rain, has increased at double the pace projected by models that aim to stimulate the global climate. Work by researchers from Taiwan and China found that the increase in rainfall intensity over the past 3 decades has been an entire order of magnitude greater than climate models predict. As for extraordinary heat waves such as those in Europe in 2003 and 2010, events so far from the norm were only projected to occur towards the end of this century. Climate scientist Jennifer Francis of Rutgers University thinks warming in the Arctic could be part of the explanation. As temperature differences between the North Pole and the tropics fall, the polar jet stream, which pushes weather systems around, is meandering more and slowing down. This means weather patterns are more likely to get, quote, stuck in place. Following the record-shattering loss of Arctic sea ice this summer, I would expect the jet stream to dish up a smorgasbord of extreme weather events all around the Northern Hemisphere, says Francis. Such a blocking pattern caused Hurricane Sandy's abrupt turn into the US East Coast, perhaps implicating Arctic ice loss. Studies of past climates suggest future weather could get even wilder. Between 5 million and 3 million years ago, for instance, the world was 2 degrees Celsius to 4 degrees Celsius warmer than today. According to a study by Kerry Emanuel of the Massachusetts Institute of Technology and his colleagues, published in 2010, rising numbers of hurricanes altered the distribution of heat in the oceans and ultimately flipped Earth's climate into a different state, with warmer tropics and far more hurricanes occurring over a much wider area than today. I think it plausible that hurricane feedback could influence the way climate changes over the next few hundred years, says Emanuel. I only wish we understood this problem better. See, marsupials are still taking it all in. Point 3. Food production is taking a hit. Earlier this year, record harvests were predicted in the US as farmers planted more to take advantage of rising prices. Instead, yields fell because of drought and a record-breaking heat. The UK had a different problem. Yields fell because of too much rain. With extreme weather hitting harvest in other areas too, global food prices are soaring yet again. That contrasts with the 2007 IPCC report, which predicted that if global temperatures rose 1.5 degrees Celsius or more above pre-industrial levels, greater warmth and higher CO2 levels would increase yields, at least in the temperate regions. Only warming of more than 3.5 degrees Celsius was expected to lead to a big drop in production. But it seems climate change is already having an adverse effect, even though the world has warmed just 0.8 degrees Celsius. Last year, a team at Stanford University in California looked at global production of wheat, maize, rice and soybeans. Sorry for that preview. Wheat, maize, rice and soybeans, crops that provide 3/4 of humanity's calories from 1980 to 2008, based on what we know about temperature, rainfall, carbon dioxide levels and how they affect growth. The analysis suggests that average yields are now more than 1% lower than would have been with no warming. Without the fertilising effects of the increased CO2, they would have been 3% lower. The negative effects far outweighed the positive ones, says lead author David Lobel. The analysis doesn't reflect the full effects of events such as floods or the recent spate of extreme bad weather. Wealthy countries should be able to compensate for these changes to some extent by altering what they grow and how they grow it, and by creating more heat-tolerant crop varieties. Indeed, they will have to. In 2008, the US National Bureau of Economic Research concluded that if the country's farmers kept trying to grow corn, soybeans and cotton in the same areas, yields would fall by 3/4 towards the end of the century. Keeping up with the pace of change will not be easy though, and with dry regions projected to get drier, irrigation water could run out in places. There is no easy way to protect field crops from extreme heat or rainfall. With the weather projected to become more variable in some regions, and perhaps globally, the biggest problem for the world's farmers could be not knowing what to expect. So, fellas, the bread could become more expensive. And, point 4, sea levels will rise faster than expected. The Summit Weather Station in Greenland sits more than 3,000 metres up atop the country's vast ice sheet. The temperature there on a typical summer's day is a chilly -10 degrees Celsius. In July this year, however, the temperature rose above freezing. At one point, 97% of the sheet's surface was melting, leading to floods that washed away bridges. This was not a one-off event. Bright snow is being replaced by dirty ice that absorbs more heat and melts faster. See, losing its sparkle below left. Here we go. Neutral grey colour is the colour that Greenland's ice sheet was in the year 2000, 12 years ago. That's how much ice there was 12 years ago. The changes towards the blue end of the spectrum indicate 12% less reflectivity. The changes towards the red end indicate 12% more reflectivity. So over there's a few areas that have had some white snow, but largely we can say that Greenland has shrunk and become darker. Along the coastline, the floating tongues of glaciers are breaking up. As these, quote, dams, unquote, disappear, the rivers of ice behind them are accelerating and thinning. Until recently, we thought it would be centuries before Greenland lost a significant amount of ice. The Arctic ice sheet was expected to grow with increased snowfall. The Antarctic ice sheet was expected to grow with increased snowfall, compensating for melting around the edges. The 2007 IPCC report assumed that the two ice sheets would contribute just 0.3 of a millimetre per year to sea level rise for the next century. Oh, 0.3 of a millimetre per year, that wouldn't be a problem, hey? Even then, many experts disputed this, and satellite measurements have since shown that the two sheets are already losing enough ice to raise the sea level by 1.3 millimetres a year and climbing. Right. Out by a factor of 4, only 5 years ago. Recent modelling by researchers from the Potsdam Institute for Climate Impact Research in Germany, as well as studies of past climate, suggest that the planet will soon have warmed enough to melt Greenland's ice sheet entirely if it hasn't already become warm enough. The question is how long the melting itself will take. Most glaciologists now think that sea level will rise by at least a metre by 2100, and possibly by as much as 2 metres. That is enough to flood many low-lying cities or render them vulnerable to storm surges. James Hansen of NASA's Goddard Institute for Space Studies in New York is even more pessimistic. He argues that as the ice starts melting, positive feedbacks will kick in, accelerating the ice loss. Satellite observations do indeed show the rate of ice loss doubling every 10 years, but, as Hansen himself points out, we cannot yet be certain that this is a long-term trend rather than a short-term blip. Then there is the possibility of the West Antarctic ice sheet collapsing, as it has on many occasions over the past few million years in response to warming. Recent discoveries about the state of the ice and the nature of the underlying topography suggests that it could be more vulnerable to warm currents in the surrounding seas than previously expected. Whether that happens or not, we should not be deceived by the small effects we are seeing now, says oceanographer Stephen Ramsdorff of the Potsdam Institute. Sea level rise is slow to start, but in the longer run it will turn out to be one of the gravest impacts and the longest legacies of the global warming we are causing now. Well, that worries me, fellas. It worries me to the point where I've spent 4 years trying to explain to people why they need to put a streamlined solar panel onto their road vehicle in order to reduce their personal greenhouse gas emissions. But people are about as quick to take up SunFoils as a good idea that, is being given to them for free as kangaroos were to take up eating bread. Whereas swamp wallabies were eating bread within 3 months of seeing a bowerbird eat bread, it took kangaroos 18 years of watching swamp wallabies eat bread. So, how long do you think it's going to be before people all over the world adopt SunFoils? Point 5. Greenhouse gas levels could keep rising even if our emissions stop. Only half of all the CO2 we pump into the atmosphere stays there. The rest is absorbed by the land and oceans. But as the world warms, they will be able to take up less. Eventually, they will begin to emit CO2. The 2007 IPCC report included projections of increasing carbon feedbacks from seas, soils and changing vegetation, but no model included the possibility that carbon locked away in the permafrost and in methane hydrates in the seabed might also be released. This is thought to have happened during past warming episodes, such as the Paleocene-Eocene thermal maximum 55 million years ago. This year, researchers from the University of Victoria in British Columbia, Canada, made one of the first attempts to account for permafrost emissions and concluded that they will lead to an extra warming of around 0.25 degrees Celsius and possibly 1 degree Celsius by 2100. The study assumed permafrost deeper than 3.5 metres would remain intact, that's a big assumption, and did not include erosion of coastal permafrost, that's a sad omission. It also ignored the fact that some carbon will be released in the form of the more potent greenhouse gas methane. In other words, it's likely to be an underestimate. Surprisingly, if we emit huge amounts of CO2, such feedbacks will actually make less difference. The more CO2 there is in the atmosphere, the less warming effect that adding some more has. So, if you're caught having sex with a goose, does it matter if you're seen fucking a duck later on? Probably not. The really worrying finding is that under certain circumstances, carbon feedbacks could lead to self-perpetuating cycles. Even if all human emissions stopped, CO2 levels would continue to rise as permafrost melted, leading to further warming and further carbon releases and further warming and further carbon releases in a feedback cycle. Simulations by Paul Higgins of the American Meteorological Society point to a similar conclusion. He says recent projections of carbon feedbacks may be overly optimistic about how much plant growth is boosted by increasing CO2 levels and how fast plants and trees colonise new areas as conditions become favourable. Even in the lowest emissions scenario, we could end up with atmospheric CO2 concentrations consistent with the worst case emission scenario, says Higgins. You still there, are you, fellas? Yeah, I'm sorry. Your hand's still sore, and we're still going on. We're still going on because we're emitting more than ever. If we stop pumping more CO2 into the atmosphere right now, if everybody got a SunFoil and did lots of other things and reduced their electrical consumption, if we stopped pumping CO2 into the atmosphere right now, we'd have a very good chance of avoiding a big hike in temperature. But there is no sign of that happening. Annual emissions fell only slightly after 2008, the biggest financial crisis since the Great Depression, and are now climbing more rapidly than ever. See, no let-up on the right. No let-up. There we have the drop-off in carbon emissions following the global financial crisis and the return onto the worst-case scenario track. And that little drop-off there was the small change after the Kyoto Protocol was signed. Right, because that's the year 2000 down there. Isn't that sad? So far, they are near the top of the IPCC's worst-case scenario. Our emissions are not slowing, says Paul Valdez of the University of Bristol, UK. That's the most scary aspect of our future. The only international agreement to limit greenhouse gas emissions, the Kyoto Protocol, excluded developing countries, and it involved only minor cuts. The US, which was the biggest emitter of carbon dioxide on the planet, never signed up, and Canada has withdrawn. Hopes for a more effective and inclusive agreement have faded. Meanwhile, China, which is now the world's biggest CO2 emitter, is investing heavily in renewable energy. But its rapid growth means its emissions will still soar. Some smaller countries have unilaterally promised big cuts, but few are investing to deliver them. On the contrary, most continue to subsidise fossil fuels and to build coal or gas-fired power stations, committing themselves to decades of continued emissions. The move away from nuclear power after the meltdowns at Fukushima Daiichi has made matters worse. Even Germany, which was leading the way on expansion of renewable energy, is now planning to build more coal-fired power plants. We're going to do virtually nothing, says Kevin Anderson of the Tyndall Centre for Climate Change and Research in Manchester, UK. Every year it looks worse than previously. So we're on a path that the 2007 IPCC report concluded would most probably lead to a 4 degrees Celsius rise in temperature by 2100. Way above the 2 degrees Celsius level it was declared we should avoid at all costs. But this worst-case scenario was not simulated with the most advanced models when the 2007 report was being prepared because of limited time and limited computing power. Those deficiencies have since been remedied. They've done the calculation. And, g'day Ant, you're on a YouTube movie. And the best estimates, in inverted commas, are now between 5 degrees Celsius and 6 degrees Celsius by 2100, with roughly a 10% chance of a rise to 7 degrees Celsius. This means many of us are likely to live long enough to experience severe global warming. We are on track for 4 degrees by the 2070s or the 2060s if the carbon feedbacks are high. Far from being alarmist, says Anderson, most scientists have underplayed the significance of the emissions story to make their message more politically acceptable. Since the last IPCC report, more sophisticated models have suggested even greater warming than the previous worst-case scenario. IPCC worst-case scenario up the top there at 4 degrees. In the middle, Massachusetts Institute of Technology Integrated Global System Model 2009 has us for 5.1 degrees. The United Kingdom Meteorological Office Model 2011 has us on 5.5 degrees. And that's going to be a problem even for fellas like you and fellas like me, because it's going to affect us here in Australia, even 3,500 feet above sea level. It's a serious problem, mate. Let's see what it's got to say. Heat stress means big trouble. Aerial view of a patch of desert-struck Australia or drought-struck Australia. Heat stress could make areas such as Australia's interior uninhabitable. In August 2003, Europe was hit by an extraordinary heat wave. In parts of France, the temperature hit 40 degrees Celsius for 7 days in a row. So many people died that a refrigerated warehouse near Paris was co-opted to store the bodies. A study in 2008 concluded that the total death toll was around 70,000. Most of the victims were elderly or ill, but not all. Heat has more subtle effects too. The productivity of people who work in non-air conditioned environments falls roughly 2% for every 1 degree Celsius rise above their comfort zone. If it gets too hot, people begin to suffer from exhaustion, heat stroke and kidney failure. Recent studies suggest the effects of climate change on human health and economic output have been underestimated. Quote, "I suspect heat stress will prove the single worst aspect of climate change," says Stephen Sherwood, an atmospheric scientist at the University of New South Wales in Sydney, Australia. "What matters is not so much the air temperatures, but the temperature of our skin. Sweating cools our skin, but is less effective in humid conditions. The combined effect of heat and humidity can be gauged by the wet bulb temperature of a sweating thermometer, a thermometer wrapped in a damp cloth. Currently, the maximum wet bulb temperatures reached anywhere on the planet do not exceed 31 degrees Celsius, but we do not expect that to remain so. All our models show a strong increase in wet bulb temperature and as a result higher heat stress and health impact," says Eric Fisher at the Institute for Atmospheric and Climate Science in Zurich, Switzerland. "It is very difficult to put precise numbers on the effects because if we are healthy, we don't just sit there sweating when it gets hot. We seek out cool spots or install air conditioning and so on. Killer heat in one country is no problem in another where people and infrastructure are adapted to it." Yeah, trouble is your air conditioner runs on a coal-fired power station, you dickhead. But there is an absolute limit. We cannot survive wet bulb temperatures of 35 degrees Celsius or more for long, even standing naked in front of a fan. And in a 2010 study by Sherwood and his colleague Matthew Huber concluded that if the world warms by 7 degrees Celsius, and we've got a 10% chance of that, parts of the world will start to exceed this limit occasionally. Eventually, vast swathes of Australia, Africa, China, Brazil, India and the United States will become uninhabitable for at least part of the year. Something similar may have happened before. A mass extinction 250 million years ago is now blamed on temperatures rising too high for most animals to survive. It looks as if we fully develop all the world's coal, develop in inverted commas, and the world's coal tar sands, and the shales, and the other fossil fuels, we run a high risk of ending up in a few generations with a largely unlivable planet, says Sherwood. This is written by Michael LePage, who is a features editor at New Scientist. Extensive links to the relevant research can be found online at www.newscientist one word .com hyphen special hyphen worse climate dash between worse and climate. Okay, so that's how New Scientist magazine sees global warming, the man-made anthropogenic global warming caused by the release of carbon dioxide, which is a greenhouse gas released by the burning of fossil fuels. We have known this was a problem since about the 1850s, when a Dutch chemist pointed out that the burning of coal for the Industrial Revolution had already begun to raise the world's atmospheric carbon dioxide concentration. It was down around 225 parts per million, and then it went up to 250 and he noticed it, and it was around 300 parts per million at the turn of the 19th and 20th century. It was around 370 or 380 parts per million at the turn of the 20th and 21st century. And I guess we're probably up around 400 parts per million or maybe more by now. I really don't know what it is, but it's bad. That's what I do know about it. And The average Australian emits 30 tonnes of atmospheric carbon per year. The average American emits about 29.5 tonnes. The reason Australians are collectively dirtier than the Americans is because there's less of us on a larger landmass and we're more spread out. So we drive more and we push our power through longer grids. We also export a shit pot full of coal, and there you have it. Australia is actually the world's filthiest carbon emitter on a per capita basis. Me personally, I weighed my firewood, I counted the LP gas litres and I counted the petrol litres for an entire year, and I emit, well, I used to emit 9.7 tonnes, I now emit 9 tonnes. The reason I was able to shave almost 10%, probably 8% off my carbon budget is because by putting a streamlined solar panel on the roof of my car, I trained it to drink 266 litres of fuel less every year, and every litre that goes in the fuel tank comes out the exhaust pipe as 2.5 kilograms. So 2.5 kilograms per litre, 266 litres per year, which is 33.25% of the pre-modification fuel burn, and that saves 3/4 of a tonne of atmospheric carbon from that one little 4-cylinder 1.8 litre Subaru, which barely does 130 kilometres a week. So I lock up 100 tonnes of atmospheric carbon per year because I pay rates on a 100-acre endangered species sanctuary. My children are both fairly normal Australians, so we'll grant them 30 tonnes emissions per year while I soak that up here. Somewhere out there's a hard-working taxpayer who makes it possible for the government to give me a disability support pension. So let's say I soak up all the emissions of the taxpayer as well. That means, left to my own devices, by running a 100-acre endangered species sanctuary, I have 1 spare tonne to contribute to soaking up the mess that you, or anybody else in the world, might care to emit. But if I can convince you, the YouTube viewer, to do a title search, a movie title search on YouTube for the word SunFoil, SUNFOIL. Be prepared for a title-nested ambush of movies I've put on the search engine. There might be as many as 180 of them there. Maybe a dozen have been made by other people who have tried my system. I haven't patented the SunFoil. I haven't tried to register the design or copyright the SunFoil. I'm trying to give it away to you people because I don't want you to shit in my great-grandchildren's atmosphere. I want you to clean up your act. I want you to help me reduce atmospheric carbon emissions. I want to try and slow down global warming. I want to be a cosmic good guy because I'm saving 33.25% of my fuel burn. In a worst case scenario, putting a panel on a car will only save 10% of its fuel burn. In a best case scenario, you might save 60%. The fleet average saving should be 35%. At the moment, the global road transport fleet is burning 45 million barrels of petroleum oil per day, and if we shave a third off that, we can save 15 million barrels of oil a day, and if we save 15 million barrels of oil a day, it means we prevent 18.75 million tonnes of atmospheric carbon emissions. If only the rest of you 7 billion will stick a streamlined solar panel on any piston engine road vehicle that you have anything to do with. It's as simple as that. And if it wasn't true, these kangaroos would not star in this movie. Warbles on a lot to YouTube. Ciao.